Hi everybody, my name is Tim, and today we're going to be talking about a part of the Fluid Flux plugin for Unreal Engine that actually comes right in Fluid Flux. It's very easy to use and implement, but it allows you to add these cool floating particles on top of the water, and I use them to create kind of a bioluminescent algae themed ambience video with these little glowing particles on the water. And we're also going to talk about how to add a little more depth and glow to the scene by using a separate Niagara 3D gas emitter to kind of fill out that scene, add a little bit more variation and a glow underneath those particles. All right, here we are in Unreal Engine. This is basically the same scene that I used for the ambience video. It's just had most of the elements, the Niagara system's taken out because they can get kind of heavy if you have a lot of them in there. But what you see here are just a couple of elements. There's the 3D gas emitter that I talked about, and then you also have the Fluid Flux Niagara actor, which is what these little blue sparklies are. So we're going to leave these here and maybe refer back to them once in a while to kind of point out some things. But I'm going to show you just how easy it is to get this thing going. So if you go to Content, Fluid Flux, so just the normal Fluid Flux folder. Let me take this search out here. So Content, Fluid Flux, where's Fluid Flux? Right there. Normally I color code these two, I just forgot to on this one. And then in here, I like to do sorting based on these little tags. It makes it easier. This is a blueprint. And you search Flux Niagara. Right there is your actor. And when I drag this in, first of all, you set up the scene as you normally would. You would, any way that you'd set up a coastline or whatever, you would do that, all those steps, which I have videos on how to do that. If you go to my video on blending coastline domains, there's a full setup instructions there. So this has all been set up already. You can see the waves going there and everything. So all you need to do then is take your actor here and drop it in. And if we go over here, you will see these are the particles coming in. And if you wanted it like that, like you're done. You've got the floating particles already on there. It reads the height of the water here and puts the particles on top. We want to fine tune it though, to be maybe a little bit finer, have a little more variation and change the color and stuff. Before we get into altering this system to make these particles look just how we want, I want to show you just how this works and how easy it is to change what's being spawned here. So by default, you'll see here the system being used is NS Flux default. Okay, that's just these glowing dots. But if you go over to Content Fluid Flux and use your little tag here to filter by Niagara system, you'll see all these different Niagara systems. And if you were to grab, for example, this Flux Floating Meshes one and drag it over, you'll see that now instead of, glowing dots, it's spawning trash and like palm leaves and beach balls and things like that. It's just something that holds something that emits something else. So if you were to take, let's see, this Flux Duckweed. If you want a duckweed floating down the water, put that on there, and now you have duckweed on there. It's a very easy way to have a bunch of different options for things you can plug in there and have them floating on the water and reacting to the height of the water. For this project, though, we're going to use the Niagara system that's actually made for this, which is NS Flux Simulation Plankton. So we're going to take this, drop it in, and this is going to look slightly different right now than it will for you when you first drop it in, because this is the one that I used for my scene already. But we can still go in and look at the different settings that I changed. So in our blueprint over here, we're going to go down to the Niagara system. We're going to open this up. I honestly don't remember what is normally here, but this is what we have right now. I wanted to add some variety, as I said before, and so I took this emitter and I duplicated it, and you'll see some of the things that I changed right now. If I go to initialize particle on this one, you'll see that the, let's see here, the sprite size mode, let's make this a little bit bigger so it's easier to read. Sprite size is random uniform, 0.5 to 1.5 for the size. And if I go to this one and go to initialize particle, it's 1 to 2. Okay, so slight difference in sizes between the different particles. We get some small, some big, and you'll see that these are just sprites. Okay, they're not meshes. You could theoretically add a mesh renderer and have meshes here, just like you saw meshes being rendered when I was replacing the different systems. But because these are sprites, it just uses basically a material to show like the color and all that. And this is what that looks like if you go in there. If I go back to this real quick, you can see material flux default sprite. So this is just what comes with it for the sprite. And again, I don't remember exactly how this was set up initially, but I believe it was just particle color going into the color here, and that was kind of it. If this isn't here, just go ahead and add this multiply node. So you take the particle color here, into there and then multiply it by some number. This is basically the intensity, the brightness of the particles. So if I go down here closer to the particles, for example, like this, you'll see that they're fairly bright. If I take this, come on, there we go, and set that to 1 and hit apply, you can hopefully tell that they're not nearly as bright. If I take this down to like 0.1 and apply, they're going to be like almost nothing, just little tiny pinpricks. If I go to 100 and hit apply, they get really bright. So we're going to set this back to 10, which is where I had it. What's kind of nice about this is it's just referencing the particle color inside the emitter. So this, I would guess, this material can be used for lots of different things as long as there's a particle color for it to reference. So if we go in here, initialize particle, you'll see the color right here. This is going to be the color of those particles. So if I click on this and I make it like, you know, reddish or green or yellow, whatever, it makes the particles that color. And so because these are basically the same emitter, just duplicated, I would need to make that change over here. So like if I wanted to have like some that were purple and some that were blue, that'd be kind of neat. And I could do that. So I'm going to undo that real quick. We're going to save this real quick. I don't really believe I changed much of anything else in the emitters other than things that are already exposed out here. So if I go out here, we've got our particles here. Already exposed here is the volume size and spawn rate. These are things that will control just the size of it and how many particles are there. So for example, if I take the volume size and make this 5,000 instead of 1,000, you'll see that the area that these particles are being spawned in is much wider. So that's how you can control the size of the thing like that. And if you control the spawn rate like this, going from 80 to like 3,000, you'll see there's way more particles. So if you wanted a lot more here, your computer can handle it. That is how you can do that. For now, we're going to set this back to 80 and 1,000. And we're going to go back into that Niagara system. And we are going to search for culling. Enable distance culling. This was something that bothered me for a little bit because I was trying to get shots and I wanted like the entire island's beaches to have particles that were visible. And the way it's set up with distance culling is when you're a certain distance away, there are no particles visible. And you have to get really close to see them. And so going into here, you can see if you enable distance culling, you see how in my viewport, a lot of them, maybe you can't really tell, the further away ones disappear. But if you disable distance culling, or if you have that enabled and then you just change the distance, you can control that and make sure that you have all the particles that you want still visible. Another thing that can be handy if you want to try to hide even more the particles popping in and popping out as they are spawned and then die is instead of just having a value here, a float, you can change this to, search for curve, float from curve. And now you have this thing which dictates over the course of its life, what size is it going to be at the beginning, at the end of its life, what size is it going to be, and then anywhere in between. And so what you could do is, I wouldn't recommend doing exactly this shape, but if you wanted to like start off its life at nothing here, okay, this is the beginning of its life, this is the end, go scale up to here and then scale back down, you could do that. Or you could have curves and make it however you want. But this is one way to make it so they aren't just popping in and popping out in case you're getting like a really close shot. Now we are actually going to reset this, and this was at 1 and 2. That's great. And I believe when I set up my scene for these particles, that's really all I changed was the color, the size, and then had 2 emitters instead of 1 so that I could have a greater variety of sizes in this system. So now we're going to talk about adding the Niagara 3D gas system to this whole scene and talk about a little bit why that was important. As I was looking for references on what a bioluminescent algae actually looked like, more often than not, I realized there's sometimes when there's just like individual particles in the water, but most of the time there's this kind of hazy blue glow with like, you know, these watery streaks going in because the particles are so fine that you don't notice individual particles. You just see kind of this cloudy haze. And so I felt like trying to get the water to glow somehow or add something that looked like that was important to make this look a little more realistic. And where I landed was adding a gas emitter with a light shining just on the gas. So right here is kind of what I ended up with, and I just duplicated this. By the way, with the Fluid Flux particle system and also this, you can just copy paste these systems and place them wherever you want. Like if I go here, you can see this is a giant system for the big particles that I would just, copy paste around the scene, move it around, add more of them wherever I needed them. And you can do the same thing with this gas system that I'm going to talk about. If you go over, I'm going to go into my folder here and go to Niagara system and you search for simple, you'll see grid 3D gas simple particle source. Select that, create it. You can name it whatever you want. We'll call it Toot Gas 2. That's a funny name. And then we enter in here. And it looks very simple, but there's also a ton of things that you could change in here. And this right now, of course, looks very fiery, and that's not exactly what we want. So I'll talk about a little bit of how we can change that to look more like this nice blue haze. So the first thing we want to do is not give this quite as much room to blow out the smoke. We want it to be very controlled and basically sit at the same level as the water. So we're going to go in to shape location, I believe, shape primitive, change it from sphere to box plane, and now we have basically the choice of box or plane. I used a plane, so now you can see here, it's still in like a bounding box, like a volume, but it's just emitting from a plane, okay? Now, of course, this still looks like fire, so we have a couple things to change. Now, one thing that's really handy to do when you're working with something like this and trying to be fine-tuning it in the scene is being able to have user parameters exposed to the details panel instead of having to do everything in the Niagara system like window here. So the way you do that is, let's say the plane size is something I want to change, like per instance. If I go here and I search for user, read from new user parameter, I click that, and now it's replaced this with something that just says user. And if I was to, here, let me minimize this. Let me drag this into my scene here. And let's make it go up near the top here. Let's go look at our fire on the water. That's crazy. Okay. Yeah, that's good. So this is the system that we just made there. Looks really intense and cool. But if I go down over here, you'll see these different user exposed parameters now. This is the one I just changed, plane size. So if I take this and I change it to 500. Okay, the plane is now 500 units wide, even though the bounding box is only this big. It doesn't have room to do it. If I make the world space size, for example, let's say 3000. So now it's got all this space, and you'll see there's not enough resolution in the simulation to fill it up because it's trying to, like, I don't know, fill up this space I told it to fill up without much resolution, so it looks bad. So what I can also do is change something like the resolution max axis. So if I go like 512, now we have extra resolution to use in this space. And basically set this to whatever you're able to do, whatever your computer's able to do. I don't remember what I did actually. Whew, that's really detailed. That's probably too detailed. Let's bring that back down to 512 for now. If I go back into here and look at add velocity, so I'm still just in this particle source emitter. If I go to add velocity and I see that there's 50 units of velocity added to the x-axis. If I change this to like 10, you'll see that that doesn't billow out nearly as strongly anymore. But if I was to give it 100, it would go out way fast and be really intense. This is one of those things that you can tune yourself to get it to go as fast as you want. So let's say we want it to go 30. I'm not saying that's correct, but we'll just start with that. Actually, let's leave it at 50 because we're going to change something else that will affect how it appears to go out and dissipate. The place we go to make most of our adjustments is over here, which doesn't have anything that seems to be exposed, but if you click on Grid 3D Gas Master, you will see all sorts of settings for things like vorticity and turbulence, buoyancy, and all this stuff. So there's a lot of fine tuning that happens to get exactly the look that you want. But some of the things that I changed were temperature, first of all, to make this. So temperature is what controls like this looking like fire. So if I go here, if I go down temperature scale, I think that was it. Set that to 0. Now we have no temperature. Now it's just the smoke. And we're getting closer already to what we would want. This obviously is like thick black smoke, but at least it doesn't look like fire. If we go to the dissipation rate density, I believe, let's set this instead of 0.25 to 1. You'll see that it's dissipating differently than it was. If we go here and set it to 0, there's like no dissipation at all. It just kind of stays there. If we set this to 3, you see it dissipates way earlier. Dissipation is like it kind of like fading into nothing. So this is one thing you can affect to make the smoke hang on longer, to billow more. You can see what it does right here. And again, if you wanted to be able to play with this more easily in the viewport and see it actually there, you could take any of these things, like the rate density, go here, user, make it a user parameter, and now you have that thing exposed right here. So you can look at it actually in the scene and be like, huh, if I go like this, I can see the one here, I can set it to 0. Look at that, it just hangs on forever. So adding these user parameters can be extremely handy to make it look right actually in the scene. If I was to go over to my actual gas that I made, there's so many settings you could play with to get the look you want. But this look here, if you look here, there's some things that are just set in the system itself, but these are all the user exposed parameters that I did. These are, you know, the vorticity, the velocity, sprite size, spawn rate, like all this stuff are things that I affected to get it to look this way. And then here's the secret to making it actually appear properly. You can add a smoke color. Okay, you can change that to look whatever color you want. But the thing that makes it actually pop is this thing here, the gas light. So what I did is I created a gigantic, that's like the light dome from this gigantic rectangle light. Okay, if I was to turn off this light, and you look at this gas here, if I turn off this light, it goes away. And the reason for that is there's just not enough ambient light to see it without this light. And this is where using lighting channels can be very handy to make things show up. So if you look at, if I search for channel, by default, everything gets set on channel 0, so that everything kind of gets lit all the same with all the same lighting and whatever. But you can fine tune these to make things only get illuminated by certain things. So this rectangle light is only shining onto channel 1. And if I go to my gas here, that's also only on channel 1. If I had this set to just channel 0, there's not enough light to actually make it appear. But what I can do is go like this, and now you see it. And I can take my gas light, and I can also have a color for this. So I have the color of the smoke, and I have the color of the light to illuminate it, to make all the colors appear cohesive and stuff. And so that's why I can have this thing show up like this without brightening everything else in the scene, because nothing else is getting hit by the light. All right, last little bonus tip for you. If you're working with animated VDBs, sparse volume textures, and you run into something like this where you have this crazy flickering. When I first saw this, I assumed it was just an editor playback error, and then when I rendered it, it would be fine. But no matter what frame rate I used, no matter what settings, it showed up like this in my renders, and it obviously looks really bad. And after some searching online, I found out why it is. If you go, so this is a blueprint that I put together, and it's just got like, you know, stick and some ropes around it, and then the actual fire here. So if I go to the torch fire and I go to my material, okay, open that up, it brings up this thing, and then the sparse volume texture, which is the animated VDB. If I open that up and go here, I have a few settings, but the one that matters is the streaming pool size factor. By default, I believe it's 3. And I realized as I was changing these numbers, it didn't seem to affect performance no matter what number I went to. So I went all the way up to 30. And it fixed the thing, because it's basically that and then the number of prefetch frames. Those things affect, from what I understand, how far ahead it's able to load frames. And so it's basically able to kind of cache them or pre-look up the frame so it's not flashing, and like it's able to catch up and get ahead. So anyway, if you run into that, streaming pool size factor, number of prefetch frames, look at those in here, save, and then it will render just fine. So that's all I have for you. Hopefully you'll get some more use out of Fluid Flux and have some fun adding particles to your water. I can't wait to see what else you make in Unreal Engine.